All right, everybody, welcome into your week one video. So this is being posted on Thursday of week two, but it's going to cover material from week one and your first quiz. So your first quiz and the material that you worked on in week one was chapter R. It's the first chapter of your textbook. So that's algebra reference stuff. So should all be kind of review. Hopefully, most of it is. I'm sure there will probably be some hiccups along the way. But for the most part, you should have seen this stuff before. So I want to start off by going through kind of like a review of what you did, what algebra is. So algebra is performing basic operations. At the very low level, algebra is just how can I move numbers around. So these operations are simplifying or reducing certain expressions, factoring, addition, subtraction, multiplication, and division, and solving equations and inequalities. So if we're going to perform operations, we obviously need to know what we're performing operations on. So the things that we're going to be looking at, the things that you looked at, were polynomials. So those are things like they're sums of terms. So we could do 5x plus 6. What's another good one? X squared plus 2x plus 1. Or maybe just something like x to the 10th power. That's a polynomial too. Another sort of thing that you looked at was rational expressions. Now, rational expressions are just polynomials over polynomials, so a quotient of polynomials, provided the bottom isn't 0. So that could be something like x plus 2 over x plus 3, 1 over x squared plus 1. So 1 is itself a polynomial. It's a constant polynomial. Or something maybe like x squared over x to the 4th plus 5. Another thing you looked at was exponential expressions. So these are, basically variables with an exponent attached to them. So if we remember, we defined exponential expressions as, so if you have a to the n, this is a multiplied by itself n times. So something you could think of like x to the 5th. So these are also polynomials, but they're exponential expressions. X to the 10th, x plus 2 to the 3rd, stuff like that. Radical expressions, we define these. So it's the nth root of a is defined as a to the 1 over n. And these things are like, you could do the cubed root of x plus 1, just the square root of a number 2. Or maybe something like this, x plus 4 to the 1/4 power. And then finally, you looked at equations and inequalities. So these are things that you're probably pretty familiar with. Maybe something like x plus 3 equals 4. Or something a little bit more complicated, like x squared plus 9x plus 17 equals -3. Or for an inequality, something maybe like y plus 7 is greater than 10. Okay, so this is kind of what we looked at. Now, if we're going to perform operations on these things, we kind of need a set of rules. So this is what I have, all these tables written out here, and we get all these rules from the properties of each individual kind of expression. So I'm not going to spend a whole lot of time on this, but this is something that I think you should do. If you're going back to review, or if you struggled with these parts of last week's session, what I think you should do is write these properties on a flashcard or on something like that and memorize them. And then every time you use one while you're solving a problem, you should write down which one you used. So I'm going to try to do that later on when we solve the problems too. So first are the properties of real numbers. Those are things we have to know. So commutativity, that just means that we can switch the order of multiplication or addition and the number stays the same. Associativity, we can move around parentheses however we like. And distribution, that basically means that you can distribute a number through a sum or a sum over a number. Properties of rational expressions. If you notice, I have these little numbers circled off to the left. So this is what's going to help me. It's going to help me recall them later. So if I'm using a certain property and I want to write down that property, I can write, for instance, R1 or something like that. Okay, so properties of rational expressions. The first one is the fundamental property. What this is saying is basically that if you multiply the top and the bottom by the same number, the overall fraction doesn't change. And we use this a lot when we're dealing with rational expressions because this is the same as multiplying by 1, right? So if you multiply a fraction by 2 over 2, something like that, s over s, the thing isn't going to change because you're just multiplying by 1. Addition. If we add two fractions together, notice that the top two numbers just add and the bottom stays the same, but that it's required that the bottom, the denominator, is the same for each fraction. So that means in order to add fractions, we have to have the same denominator. And then subtraction is the same. We can think of subtraction as addition of a negative, and that's why it looks very similar. Multiplication is done just by multiplying across the top and multiplying across the bottom. So we have P over Q times R over S is equal to PR over QS. That's P times R on the top and Q times S on the bottom. And finally, division is just done similar to multiplication. What we do is we just flip over the second thing and then multiply. So if you notice, I have P over Q divided by R over S. I just flip R over S, and I have P times S over Q times R. Note here that R is not equal to 0 because it doesn't make sense to divide by 0. And that all of these things, in all of these fractions above, it's necessary that Q and S are also not equal to 0 because you can't divide by 0. So it wouldn't be a rational expression if either were 0. Moving on to properties of equality and inequality. So the first property of equality, we have that if two numbers are equal and you add the same number to either side, that quantity is equal to. So if you think, like say, A is 2 and B is 2, right? As long as you add the same number to both sides, so if you add 3 to A and add 3 to B, you're going to get 5 on both sides. And then similarly with multiplication, if A equals B, then AC equals BC. So all this is saying, all this lets you do is if you have two sides of your equation, you can add a number on either side as long as you add the same amounts to the opposite side. And then similarly, you can multiply one side by a number as long as you multiply the other side by a number. And then properties of inequality, these are basically the same. With one kind of exception. So if A is less than B, then A plus C is less than B plus C. You could take that if A is greater than B, then the same thing would happen. It would just be a different sign. The next two are kind of important. So if A is less than B and C is greater than 0, then AC is still less than BC. So that's kind of the way we think about it. But notice the third property. If A is less than B and C is less than 0, so negative, then AC is greater than BC. Now, I believe your book actually has a typo here that says that it's the same as the one before, but that's not true. And we can think about that. So if A is less than B, let's just do it. So 2 is less than 3, and we're going to let C equal negative 1. Then 2 times negative 1 is greater than 3 times negative 1. And this is true because this is negative 2 and negative 3. So clearly negative 2 is greater than negative 3 because it's less negative. The last couple things we have here, exponents and radicals, you're going to see these a lot, so it's really good to know how to manipulate these. So when you multiply two things with the same base, that's what A is called here. This is a base. So I'm going to highlight it down here in the radicals too. When you multiply two things with the same base, the exponents add. When you divide two things with the same base, the exponents subtract. When you take an exponent or an exponential expression to a power, then you multiply the exponents. And then for the fourth and fifth properties, this just says that exponents distribute across multiplication and division. So if you take a product of two things to a certain power, then that power gets distributed to each of the individual things in the product, and similarly with division. And then with radicals, some of these things are less useful than others. Most of the properties of radicals are going to come from the fact that, remember this, so the nth root of a is equal to a to the 1 over n. So all of the properties that applied to exponentials also apply to radicals. But some of the other properties to look out for, the nth root of a to the nth power is a. This is just because you have basically a the 1 over n to the nth power. If you do the multiplication there, you'll get a to the 1. If you bring that nth power inside, you get either the absolute value of a if n is even, and just a if n is odd. If you have two different bases, but the radical is the same, then you can bring those two bases together under the same radical. So that's the third property. The fourth property is the division analog of the third property. So if you have two different bases with the same radicals that are being divided, you can bring them under the same radical as a division. And then the fifth property here has just to do with nested radicals. So if you have the mth root of the nth root of a number, then you have the m times nth root of that number. So that just allows you to simplify it a little bit. So these are all of the properties, and for this chapter, for the chapter that you just did, this is kind of like the nuts and bolts. There are maybe 2 or 3 other things that you need to know outside of the definitions. And that would probably be something like the zero product property and the quadratic formula, which we'll cover in a little bit. I don't know if we'll even see the zero product property. Actually, yeah, we will. We will when we do one of these problems. But again, I would strongly recommend that if you're having any difficulties with these, that you write these on a flashcard, study them, and then when it comes time to do the problems, write which properties you're using as you use them. This isn't something I'm just making up. This is actually something I did when I took a pre-calculus class in my undergraduate studies. All right, let's move on to some problems. This is probably why most of you are here anyway. So I think I picked out 6 exercises. I believe it's 4 from the quiz and 2 from the homework that were of particular difficulty, or I felt kind of represented a wide range of stuff. So for the first one, we have just, this is from the first section. We're talking about multiplying, adding, dividing, subtracting polynomials. And it just asks us to perform the indicated operation. This indicated operation is multiplication. So how do we do that? Well, we use FOIL. So if you remember, FOIL, if you want to think about FOIL, some people, they don't like to use the idea of FOIL. This is better for, it's a little bit harder to do. My voice keeps breaking. I don't know why. It's a little bit harder to do when you don't have 2 binomials. So we have this 3-term thing over here, so we can't really use FOIL, but the idea still applies. And you'll see kind of why. So FOIL is first, outer, inner, last. So first terms of the two, then the outer terms, then the inner terms, and then the last terms. So you can remember that if you want. It's kind of up to you. We'll basically we'll show you how this goes. So all you're gonna do, the way that I think about it is, first I'm gonna distribute the 3p. I'm gonna go here, and then to the second term, and then to the third term, and then I'm gonna distribute the -1 to the, nobody can see that. That's not a good color. Let's go U. Okay, then I'm going to distribute the -1 here, the -1 there, and the -1 there. Okay. So first, I have distributing the first stuff. I have 3p times 9p squared plus 9. Oh, I'll write it out. I don't want to skip any steps. Plus 3p times 3p plus 3p times 1. And then I have, so we'll just do this, -1 times 9p squared minus 1 times 3p. And then maybe I can just make this a little bit smaller so it all fits. Good. -1 times 1. All right, so now I do the multiplication just term by term. I have 3 times 9 is 27. P times p squared is p cubed. Then I have 3 times 3 is 9. P times p is p squared. 3p times 1 is just 3p. Subtracting 1 times 9p squared. Subtracting 1 times 3p. And then subtracting 1. If you notice here, I have a -9p squared and a +9p squared that cancel out, and then a -3p and a +3p. So I'm left with is 27p cubed minus 1. So this actually has a special name. You probably didn't know it when you did this section. Maybe you did. But when we see this actually in the next section, in section 2, when we talk about special forms of factoring. So this is actually a difference of cubes. So what we did was kind of we basically reverse factored a difference of cubes. So this is kind of a little bit of like a setup, a little bit of foreshadowing of something you might see in the future when you did this problem. Now that you do know what a difference of cubes is, you can look at the form of the original problem and say, hey, maybe I know what this looks like. Maybe I know this is a difference of cubes, and you can jump straight to the solution. But generally, it's much easier to factor a difference of cubes than it is to see what one looks like factored and put it back together. So oftentimes it's best just to distribute like we did. All right, so that was, I think, the only problem from section 1 on your quiz. Now we have a problem from section 2, so this is just factoring. This is also on your quiz, and we're just going to factor this polynomial. So the thing that I look for especially when I have just a z squared out front or a letter squared, nothing in front of it. Let's see what color I want to use. Let's use this one again. So I want something that adds, I want two numbers that add to this and multiply to this. Okay, so if it multiplies to 20, that means that I know that it's either going to, the two numbers are going to either be both positive or both negative. If one was positive and one was negative, then the resulting product would be negative, and I have a positive number. Now, because I know that it has to add to 9, that means that the numbers that I pick actually both have to be positive. Because if I add two negative numbers, then when I add them together, I also get a negative number. So I know that my two numbers have to be positive. So now I think, what multiplies together to give me 20? So 20, I can do 1 or 20. I could do 2 and 10. And I could do 4 and 5. So to me, this adds up to 12, this adds up to 21, and this adds up to 9. So this is the one that I want. So what this means is that I can write this as z plus 4 times z plus 5. Now, this is not always this easy. Sometimes you have to do a little bit of guessing and checking, right? So this worked out really well for us. It worked out really well, too, because 20 only had a couple different options for what could multiply together to get it. Sometimes this doesn't happen at all. Sometimes you have to go straight to the quadratic formula. So usually the first thing to do is to do what I did. When you're asked to factor something like this, that's just quadratic, then you try to do it just by finding a couple numbers that work. If that doesn't work, maybe you use the quadratic formula. Maybe you try a different method. But this is usually the fastest way to go about it. And a good thing to do when you did what I did is to FOIL it, to distribute it back out. So this we think is the answer. We're going to check. So we're just going to check by foiling it. And we should get the thing we started with. So I have z times z plus z times 5 plus 4 times z plus 4 times 5. And this is equal to z squared plus 5z plus 4z plus 20. And now you can see why I needed two numbers that multiplied to 20 and added to 9. Because this is equal to z squared plus 9z plus 20. Which is exactly what I wanted. All right, good. We did the right thing. Moving on. So this is another quiz question. This is your first equation that you get to solve. So this is a linear equation, which means that it's the equation. Well, one, it means it's the equation of a line. Two, it means that the variables it's what's called degree 1, which means they're not to any power. So it's just their power. The power on the variables is 1. So that's like right up here. You can think of like an imaginary 1 being here. So in order to solve this equation, the idea is, in order to solve any equations for the unknown, which in this case is r, we have to get r on one side and then all of the numbers on the other. And we do this by using our handy dandy properties that we learned earlier. So if you notice here, we didn't use a lot of the properties. We did use some stuff maybe in R 2.7 here. The distributive property of real numbers, which isn't really a huge one because that's one that most people remember. But here we have to use some properties. Mainly we're going to see probably just regular multiplication, real number properties again. But it's important. We are going to see properties of equality. So that's where if you have two numbers that are equal, you can add the same thing to both sides. So first thing I want to do is I want to isolate all these r's. So what I'm going to do is I'm just going to rewrite this. I'm going to distribute this 5 through. I don't know what happened there. So let's We're just going to do this kind of in a line. Okay. So now I have two r's on the right side, and I can collect those together. So I can, that's what's called adding like terms. So how I do that is I just add the coefficients, which are the numbers in front of them. So on the left side, I'm also going to add the 2 and the 5. So I have negative 2r plus 7 equals 6r plus 4. And then what I can do now is use the addition property of equalities. So what I'm going to do is I'm going to, let's see, how do I want to do this? Let's add 2r to both sides, as well as negative 4. So we're going to, let's do it in a different color. So we'll do plus 2r minus 4 plus 2r minus 4. So this is, let's go back up to our properties. This is EQ1 that we're using. So what does that do to my next line? Well, if you notice here, these two things will cancel out, and this negative 4 and this positive 4 will cancel out. So over here I'm left with 7 minus 4 is 3. And over here I'm left with 6r plus 2r is 8r. And now I use, so now I'm going to multiply by 1 over 8. This is the same as dividing by 8, but I'm going to call it multiplication just so I can write EQ2. Now this is the other property of equalities, that's the multiplication property. So on the left side I have 3/8, and on the right side I have r. So I have r equals 3/8. Now let's just make sure I didn't make any mistakes along the way and that answer is actually correct. Well, I actually did make a mistake along the way. So let's go back and see if I can figure out what I did wrong. Oh, I see it right now. So if you notice, and this happens all the time, so, you know, expect me to make mistakes, just as you yourself expect to make mistakes. So this is going to be one of the biggest things that you'll notice, especially in a calculus class. The majority of the things that you're going to get wrong on a quiz or on a test will probably have to do more with dropping a sign or an arithmetic error or something like that, rather than the actual thing you're trying to do itself. So if you notice here, I dropped a negative sign when I distributed this 5. So let's change this, and that's going to change our answer a little bit. So this is actually a negative 5, which means 2 minus 5 is negative 3. And then negative 3 minus 4 is negative 7. All right, good. So I got lucky because I know I have the answers in front of me. I have the instructor's version of the textbook, the physical copy, so I can check my answer and make sure that what I did was right. You don't always have the same luxury all the time. So a good thing to do, if you have the time anyway, is to go back and double check your work. The better thing to do is to take your time. I didn't take my time. I went a little bit too fast. So the better thing to do is to take your time, and then you should be at the point where you can minimize your mistakes. But mistakes are going to happen, and you shouldn't really beat yourself up over it. All right, let's move on to another problem from the same section that was also on your quiz. But this one is quite different in how we solve it. So there's actually two different methods that I'm going to use here. They say you can solve it by factoring or solve it by using the quadratic formula. So I'm going to solve it by factoring first, just because that's generally the quicker way. And then we'll also use the quadratic formula just so you are sure of how that works. Okay, so first we're going to try to factor this, right? So I want to factor what's on the left side. This is how I usually start this out. I know I have an r here and an r here, and because it's 2r squared, I know one of them has a 2 on it. Now I just need to figure out what's going to be on the right-hand side. So there are a few different options I have here. Now, when you start to factor more, you will kind of get used to how this works. It's a little bit harder to see right off the bat. Some of you might be able to already see it already, and that's great. But for some, it's a little harder. So what I'm going to choose is -1 minus 5 halves. And why do I do that? Well, so what I see here, or excuse me, that's wrong, not 5 halves. It's -5 here and -1 here. So this gives me what I want here. So I have -5, -1 multiplying together to 5. And now, if I think about it, if I multiply 2r into -1, that's -2r. And then -5 into r, that's -5r. So adding those two together gives me -7r. And then the 2r times r gives me 2r squared. So you can verify this yourself if you want, that this is actually what it factors out to. But we don't really have to, because if we do the quadratic formula correctly, we should get the same answer. So I'm not going to do that. We'll see that we get the same answer through the quadratic formula. Okay, so let's erase these little marks. So we factored the left-hand side, the right-hand side stays the same. Now we use something called the zero product property. And what this says is that if you have two things, a product of two things that equals 0, then one of the two things that you're multiplying has to be 0 itself. So this gives us two options. This either means that 2r minus 5 equals 0, or r minus 1 equals 0. So those give us two possible answers. This one is r equals 1. This one is 2r equals 5, or r equals 5 halves. And then notice we used both. In both of these, we used EQ1, and in the first one, we used EQ2. Okay, so now we can try it a different way and use the quadratic formula. So with the quadratic formula, we have r is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Right? So this should give us what we want is 1 or 5 halves. And here, the reason I wrote this in red is we have our a here, b here, c here. So I'll write it right down here. A equals 2, b equals -7, and c equals 5. So doing a little bit of math, go away. We have r is equal to negative 7 plus minus square root of negative 7 squared minus 4 times 2 times 5 all over 2 times 2. Now this is equal to, so negative 7 is positive 7. On the inside of this, we have 49 minus 40. And then this is all over 4. I might have to make some room here. Squish. Okay. And then on the inside, notice this is going to be 7 plus or minus square root of 9 over 4. And the square root of 9 is 3. So 7 plus or minus 3 over 4. Okay, so that means I have r is equal to 7 plus 3 over 4, which is 10 over 4, which equals 5 halves. Or r equals 7 minus 3 over 4, which is 4 over 4, which is 1. Will fit. There we go. Good. So I got the same two answers. So I knew that my factoring was right. You know, I wouldn't suggest doing it two ways if you had to do it on a test or anything like that. But this is more of a proof of concept of that my factoring worked. Another way that you could do it is obviously when you factor it, a great way to check it is just redistribute and see if you get what you started with. Whichever method that you prefer here to solve this equation is fine. Notice that when you use the quadratic formula, you have to have something set equal to 0. That's how we have, why we get this r equals thing. Okay. All right, so that's it for the quiz problems. We're going to do 2 homework problems to finish this off. This is, I believe, one from, what is 6? Is that exponentials? Yeah, exponential expressions. And then one from 7, which is radical expressions. These are pretty quick, so I'll wrap it up at the end of this. So the first problem here says simplify and write with only positive exponents. So you learned, or you should have learned that anything to like a negative power is the same as 1 over that thing. So specifically a to the negative n is equal to 1 over a to the n. Now let's see what property that actually uses. It should be one of these properties, right? Well, I skipped right past it. Okay. So if we think about this, it's property 2. It doesn't really seem like it, but it is. So if you recall, so property 2 says, so this is E2, and this says that AM over AN is equal to AM minus N. Well, here we're on the right-hand side. We're starting there, right? So we have a to the minus n. Well, it doesn't look like a to the m minus n, right? It doesn't look like the same thing, but it is, because really what there is there's a hidden 0. So 0 minus n is the same as just minus n. So this is equal to, if we follow the path back up, that means this is equal to a to the 0 over a to the n. But a to the 0, any number to the 0 power is just 1. So that's where we get. That's where we get this this property here. Okay. So back to our problem after that little aside. So we need to simplify and write this with only positive exponents. Now, I would love to take this thing and put that n on the bottom and that m on the bottom and call it a day, but I can't. And the reason I can't is because there's a subtraction sign between them. So what that means is that I have to somehow separate them from that subtraction sign. I have to get them into their own parts. And the way that I'm going to do that is I'm just going to use a property of rational expressions. It's the subtraction property, right? So it's just if I have the same denominator, then the subtraction of if the subtraction of two rational expressions is just the subtraction of the things on the top. So this is, I believe, let's take a look. It never hurts to look. R3. Okay. So this is R3 here. Now this, what we can do now is we can bring our n and our m down. So this is 2, and then this is going to be, when we bring it down, it has to multiply the entire thing on the bottom. So you need to be careful that we don't just put it out in front of one of these letters. Okay, great. I've successfully written everything with positive powers, but I haven't simplified this yet. So in order to simplify this, I need to, we use star here. I need to bring these two rationals together into one expression. And how I do that, again, is I need to find a least common denominator. So the least common denominator, if you don't see it right away, it might seem a little bit difficult to see at first. Really, the way that you do it is you find the least common multiple of the denominators, right? So one thing that I know each of these divides is, well, here, I'll show you. So if I write, what I'm looking at here is I'm thinking, what is something that both of these divide? And that's nm m plus n squared. So that's the least common denominator that I find. I don't think you'll find a smaller one. Remember, when you do subtraction or addition, it doesn't always have to be the least common denominator. That's generally the one that you want, but you can find any common denominator. So any common multiple of the denominators. The one that I see is nm m times m plus n squared. So that's what I'm going to use. So in order to get that, on the left-hand side, I have to do 2 times, so this is what I have here. And then I have to multiply in an m on the top and bottom. And then on the left-hand, or on the right-hand side, I have to do the same thing, but with an n. This is getting a little messy. Okay, now this is what we call the fundamental property, right? This is multiplying by multiplying the top and bottom by the same number. So this is R1. So we're gonna sneak this down, give us a little room. Okay, cool. So what that means is now I have 2m over nm n plus m squared minus 2n over nm n plus m squared. So I have the same denominator, which means I can bring it together. Let's clean this up a little bit. Okay, and again, just to try to stay as on it as possible, this was R3. This is the subtraction property of rational expressions. And then finally, to make it look nice, I realize I can factor a 2 out of the top. And that is the most simplified way of writing this term. Okay, so that's about it for that problem. This last one's pretty quick once we see it. So all this says, it just wants us to write this as a term with one radical in it, basically. Obviously, you can see here we have two radicals. So the key in doing this problem is remembering that the nth root of a, by definition, is a to the 1 over n. So if you remember at the start of this video, I said this fact means that all of the things that apply to all of the properties of exponential expressions or exponents also apply to radicals. So what we do is we write what we have above. By definition, this is just a to the 1/2 times a to the 1/3. And then by the property, this is the first property of exponents, so this is E1. We have, by the property of multiplying exponents with the same bases, we know that the exponents add. So this is a to the 1/2 plus 1/3. So now we just do a little bit of fraction addition. We say, okay, what is 1/2 plus 1/3? So think about this as maybe like being in a little bubble off to the side, a little thought bubble. That's an awful bubble. Let's redo this bubble. Maybe we'll do it on the right side. So I have 1/2 plus 1/3. I need a least common denominator. I think that's 6. So 3/6 plus 2/6. That's 5/6. Okay, so this is my thought bubble. Me doing a little bit of a fraction addition. Okay, so from that thought bubble, I get that this is a to the 5/6. And something I didn't write down, but that is in your book, is that it wants this in radical form. So we know also the book says this, that a to the mn is equal to the nth root of a to the m. So using that property here, this little star, we have that this is equal to the 6th root of a to the 5th. And that's it. All right, everybody. Hopefully this worked out well for you. Please send me some emails with some comments on what I can do better next time. If you'd like to see something different, please let me know. I'm open for change. Also, remember that I changed my office hours so that it's by appointment only through Zoom. I think it'll work better because I'll be using this iPad and we can write some problems down and work through them together. But that's it for today. Have a good day, folks.